Okay, so I'm just going to go through a few of the 2019 FRQs. These are 2019, just so that you can, I don't know, see some recent ones. You know you can have a calculator out at all times. You also can have your little like cheat sheets out, so that whole like when you see these words, do this math, that's a good thing to have out. And whatever else resource-wise you can have out or you have, make sure you have that out. All right, so number 1, fish enter a lake at a rate modeled by the function e, given by e of t, which is this. So e of t is my rate entered. Okay. Fish leave the lake at a rate modeled by the function L. So L of t is rate leave. Okay. E and t are measured in fish per hour, and t is measured in hours since midnight. So, part A. How many fish enter the lake over a 5-hour period? So I'm just talking about enter. Except E is the rate entered, not the number entered. So I want to go from rate entered to number entered. That says entered. You do that by integrating. So I'm going to integrate E of t, dt, you're going from a rate to an amount, from 0 to 5. And you have a calculator, so just put that in your calculator. You're going to use Math 9. Do not bother integrating that by hand. All right, so Math 9. My lower bound is 0, my upper bound is 5. This calculator I have at home is pretty print, so that comes first. And then I put in 20 plus 15 sine. I'm going to put that pi t or pi x in parentheses, just since they're both in the numerator, and then divide by 6. Don't forget the x at the end with dx. Also, make sure that your calculator is in radians, not degrees. And you get 153.457, which is not quite enough to round to the next whole number. It says give your answer to the nearest whole number. So this would be 153 fish. I know that's weird. Let me just double check with the key, but I'm pretty sure that you don't round up if it's not over 5. Yeah. Okay, so 153 fish. There's part A. So that's the number of fish that have entered. So I took my rate at which they enter and integrate it. And now I got the number of fish that entered in the first 5 hours. Part B. What is the average, important, number of fish that leave the lake? So again, I'm looking for average number of fish. So I'm going to integrate the number of fish that left, L of t, dt. This would get me number of fish that left. And then to average, I'm going from 0 to 5. To average, I have to divide by 1/5, or multiply by 1/5, divide by 5. All right, so again, I'm just going to plop this into my calculator. I've got Math 9 from 0 to 5. L of t is 4 plus 2 to the 0.1 t squared or x squared dx. And then don't forget to divide by 5 to find the average. So this is 6.059. It doesn't say anything about round. So you just leave it. So 6.059 fish are the average number of fish that left per hour. So again, we were going from a rate to a number of fish. This one is a decimal because it's an average number of fish. I don't know that that's even better, but it doesn't say round, so we're not going to round. Next, part C. At what time is the number of fish, is the greatest number of fish in the lake? Greatest number, this means max number. So if you're trying to find the maximum number of fish, that means you need to derive the number of fish, which means you need the rate of the number of fish. which is perfect because that's what we have. We have the rate at which they enter and the rate at which they leave. So the rate of change of the number of fish is enter minus leave. However many come in minus however many leave. And to find the maximum, derive and set it equal to 0. So I'm going to do E of t minus L of t equals 0. I'm also going to put this in my calculator in the y equals. So I'm going to put in my y equals, I'm going to put E of t, 20 plus 15 sine, open parentheses, pi x, close, divide by 6, close, there's my first one, minus, and all of L. So I'm going to put L in parentheses. So I have 4 plus 2 to the 0.1 t squared or x squared power, close that parentheses, and graph it. So what I put in my calculator is, in y equals, I put E of t, 20 plus 15 sine of pi x over 6 minus, open parentheses, 4 plus 2 to the 0.1 x squared power. And now I'm going to look for where this equals 0. So that's how you put it in the y equals, so you can see it graphically. And you can just see where it crosses the x-axis. It tells me from 0 to 8. So I can make, if I want to make my window different, I can make it from 0 to 8, or your standard window is going to be 10 to 10 anyway. So 8's within it. So this is equal to 0. Look at where y equals 0. So on my graph, I'm going to use second, trace, and go to 0. And then you want the 1 that's between 0 and 8. So I am going to look, the first thing that comes up is a left bound. So I'm going to go until I see my cursor, press enter, and it switches to right bound. And then I'm going to move that cursor to the other side of the x-axis, press enter. Always enter through guess. And then x is 6.203. And we just solved for time. I guess it's t. I shouldn't use x. I should use t. And this is hours. Okay, so to justify that this is a maximum, I'm going to make this fit. Make it smaller. And then make it fit. You can make a sign chart and look at either side and show that it switches from one to the other. Or you can just plug in a number on either side of that, right? You could do like E of 6. Wow, hold on. Okay, it looks a little better. E of 6 minus L of 6 and see what that is. And then look at E of 6.203 minus L of 6.203, and then do something bigger. E of 6.5 minus L of 6.5. And just plug them in. Again, you can kind of just look at it at your y equals. You could do it in your table. E of 6 minus L of 6 is 3.874. Am I writing? 3.874. We looked at this one, it is 0. And then hopefully we get a negative number if I was to put in 6.5 or even 7. My table, I didn't change my count. So it's counting by 1. Okay, here we go. Negative 6.583. So you can say when time is less than 6.203, the number of fish, you could say E of t minus L of t is greater than 0. At time equals 6.203, E of t minus L of t equals 0. And then at t is greater than 6.203, E of t minus L of t is less than 0. So that means when time is 6.203, the number of fish is maximum. Is the greatest. Number of fish is maximum. Sounds funny. But you don't, I mean, they're not judging your grammar, so that's fine. You can say it however you want. Or your handwriting. But please write legibly, because your readers are going to be even more frustrated than normal because they're doing it in their homes this year rather than like out in a beautiful city grading these. So that would be your justification. So here's your answer, 6.203, and then here would be your justification. And part D, is the rate of change in the number of fish increasing or decreasing? Okay, so the rate of change in the number of fish. So the number of fish, is it going to be positive or negative? That will tell me increase or decrease. Let me prove this. Okay, so the rate of change of the number of fish is E, I just made it smaller, E of t minus L of t. This is rate of change of number of fish. Do you want to know, is this increasing or decreasing? Which means I need to derive this to know how it's changing. Is it going to be positive or negative? If it's positive, the rate of change is increasing. If it's negative, the rate of change is decreasing. So you're looking for a change in the rate of change, which is how you should know to derive. So I'm going to not do this by hand because you have a calculator and we are doing all of this virtually. You have the ability to just use your calculator. Do not try to derive by hand and make a mistake doing chain rule, or that L of T1 is like a special formula. So just don't do it. So I'm going to derive. So I'm going to do E prime of T minus L prime of T at 5, at t equals 5. So E prime of 5 minus L prime of 5 equals, and I'm going to use math 8 here. So math 8, that's my derivative one. E prime of 5, so dx going in is 20 plus 15 sine in parentheses pi x divided by 6 at 5, enter, minus math 8, the other one, dx 4 plus 2 to the 0.1 x squared. Oh, I just typed that in the wrong place. Dang it. Minus math 8 dx 4 plus 2 to the 0.1 x squared, and x is 5, and you get a negative 10.722. So since it's negative, so since E, ooh, what just happened? Edit, undo writing. Since E prime of 5 minus L prime of 5 is less than 0, it's decreasing. Perfect. That's one. Next. The velocity of particle P moving along the x-axis is given by the differentiable function v of P, where v of P is measured in hours, is meters per hour, and T is in hours. Selected values of v P of T are shown. Particle P is at the origin and time equals 0. Justify why there must be at least one time for T between 0 and 2.8, 0.3 and 2.8, which the acceleration must equal 0. Okay, so the derivative has to equal 0. The only thing that we know that says the derivative will equal 0, well, a lot of times when you're talking about a derivative being equal to 0, you're talking about an extrema, a maximum or minimum. So you could say that since this is a differentiable function for all t, it must hit an extrema according to the extreme value theorem. Or you could use the mean value theorem considering the fact that maybe the slope is 0. But I don't think the slope is 0 there. So that's probably not the better option. Okay, the slope is 0. I'm dumb. I was looking at 0.3 to 4, not 0.3 to 2.8. So part A. where the derivative acceleration, which is v prime of t, equals 0. So again, you can use extreme value theorem or mean value theorem, either way. So you could, if I'm going to do mean value theorem, I'm going to do not f, this is not f, this is v. V of 2.8 minus V of 0.3 over 2.8 minus 0.3. So we have V of 2.8 is 55 minus V of 0.3 is 55 over 2.5, which equals 0. So according to the mean value theorem, the derivative v prime of t must equal 0 somewhere on 0.3 is less than t is less than 2.8. That's it. If you did extreme value theorem, you would say since the function is differentiable, according to the extreme value theorem, there must exist a maximum or minimum, which implies that the derivative is equal to 0. So you would have to make a little bit more like wordy connection using the extreme value theorem, whereas mean value theorem is slope. So that's a nice, quick mathematical proof. Well, it's not like a real proof, but like proof to them. All right, that's part A. Part B. Using a trapezoidal sum with 3 subintervals to approximate 0 to 2.8. So I'm not including the 4. Ignore that. I'm going from 0 to 0.3, 0.3 to 1.7, 1.7 to 2.8. It is delta x. So from 0 to 0.3 is delta x, y plus y over 2. So delta x is from the interval from 0 to 2.8 of v p t dt. I've got 0.3. My two y values, 0 plus 55 over 2, plus my next delta x, 1.4, y plus y, 55 minus 29 over 2, plus my next delta x, from 1.7 to 2.8, that's 0.9, no, it's 1.1, of negative 29 plus 55 over 2. And I'm just going to put this in my calculator. 55 divided by 2 times 0.3 plus 1.4 times 55 minus 29 divided by 2 plus, open parentheses, 1.1 times negative 29 plus 55 divided by 2. We get 32.5. All right, I missed a parenthesis when I was typing, so my answer is not correct, which is why it's always good to do it twice. And then if you get two different answers, do it a third time and go with that one. So you get 40.75. I just missed a parenthesis in the negative, which is the horrible place to miss it. It doesn't say anything about units, but you could go back and just say it's meters, right? Because if you're integrating velocity, you get meters. Well, you get position, which in this case is defined in meters. Cool. So yeah, I always, whenever I have like negatives and fractions and parentheses, I always do the math twice. I noticed, like, it took me 2 seconds, and I noticed that I had a missing parenthesis. I actually didn't notice it until I did it the second time. This isn't letting me touch me. And then I realized I was missing something. All right, part C. A second particle Q moves along the x-axis so that its velocity from 0 to 4 is given by vq of t, which is this function. Find the time interval with the velocity is at least 60 meters per hour, and find the distance traveled. So I'm going to set it equal to 60, not 0. 60 equals 45 square root of t cosine of 0.063 t squared. And I can either like put this in my y equals and search for 60, which will take a long time, or I can just subtract 60, put in my y equals, look for 0. So I'm going to do for that 0 or minus 60. So I have 0 equals 45 square root of t cosine 0.063t squared minus 60. Put in y equals. Look for where y equals 0. So give me 1 second. Okay, so I just put it in my y equals. I'm looking for from 0 to 4. So using my second trace, 0. I am waiting to see my cursor. Here it is, left bound, enter, move to the right bound, press enter. My y value is 1.866, but I have another one. So second trace, my right bound, enter, or left bound, enter, right bound, enter. My next one is 3.519. You could plug it back in and make sure that 60 is between it, but it's going to be between those two values. But if you're not sure, choose a number in between them and see if you get 60 or something bigger than 60. So if I choose like 2, 45 square root of 2 times cosine 0.063 times 2 squared, which is 4. Left off the cosine. That's, wow, I'm struggling. Square root of 2. Stupid calculator errors, which is honestly how a lot of mistakes happen. Yeah, you get 61.629 when you plug in 2, so clearly it's between there. So the distance traveled, I'm going from velocity to distance. I don't know why I have y equals as these. These are x values. T equals, T equals. So part 1 says find the time interval for which the velocity is greater than 60. So you could say VQ of t is greater than 60. At 1.866 is less than time is less than 3.519. And then to find distance, it is the absolute value integral of velocity. So I'm going to integrate from 1.866 to 3.519. That integral, or that absolute value of that v of q, which is 45. You don't have to write it out. Don't waste your time, especially like on stuff like this. Just write v, q, t, d, t. Put it in your calculator. Math, 9. From 1.866 to 3.519. And my absolute value is under math number. And it is 45 square root of x cosine 0.063x squared dx. And you get 106.109 meters as my total distance traveled. All right, last part. Part D. At time t equals 0, particle Q is at position x equals -90, using the result from part B and the function from B of Q from part C, approximate the distance between the particles. So we know at time equals 2.8, position, which I'm going to use x of P, particle P, is 40.75 meters. We found that in part B. Now to find out what the position of B of Q is you're going to start with -90 and then add the integral from 0 to 2.8 of VQ of t dt and put that in my calculator. So -90, math 9, from 0 to 2.8 of V of Q, 45 square root of x cosine 0.063 x squared dx. You get, Come on, calculator. Stop thinking. You get, wow, calculator is dying on me. 45.937. So the distance between them, just subtract 45.937 minus 40.75 equals 5.1.187 meters. Again, you shouldn't really box your answers. I'm just really horrible at that. I do it. So that is the second FRQ from 2019. Okay, this third one, I always think integral graph type questions kids seem to struggle with. So I feel like this is a good one to practice. It says the continuous function f is defined on a closed interval from -6 to 5. Notice that the graph only shows from -2 to 5. The figure above shows a portion of the graph consisting of 2 line segments and a quarter circle centered at the point 5, 3. So this is my quarter circle, right? So I'm going to erase that, but that's where that circle would be. So it is known that the point 3 minus square root of 5 is on the graph of f. So if the integral from -6 to 5 is 7, find the integral of -6 to -2 and show the work that leads to your answer. So -6 is not on my graph, but I know that the integral from -6 to 5 of f of x dx, this can be made up in parts. I can do part of -6 to 5, I could split it into pieces. So I can do the part that I can't see, -6 to -2, plus the part that I can see, -2 to 5. That's just splitting it up into like the 6 to -2. Again, -6 to -2 is what I can't see. I don't see that graphically. And the -2 to 5, I can see graphically. And if you're trying to integrate and all you have is a graph, you're doing area of shapes. So I know that this portion is 7. So I have 7 equals, that was given to me here. The integral from -6 to -2 of f of x dx plus the integral of -2 to 5 of f of x dx. Now this portion from -2 to 5, I can find this. This is the area of the shapes. So I can find out a number there. So I have 7 equals, this I don't know, -6 to -2. That's also what the question is asking you to find. So of course you don't know that. And then I'm going to add the area of these shapes. So from -2 until 5, I'm going to add up all of the areas of the shapes between the curve and the x-axis. So this one is a triangle, 1/2 base times height. So I'm going to have to move this. I will group this all at the end, but I'm going to need this room here. So, so I'm going to press this. So that is a triangle, 1/2 base times height, 1/2. My base is 1, my height is also 1, plus a negative, because this portion is underneath. So now I'm going to do this portion. That's underneath, so I'm going to minus 1/2 base of 1, height of 1. Okay, that's those. Then I've got the next one. This portion, oh, no, I skipped one. Then I've got this portion, also a minus, 1/2. Base here is only 1/2, height is still 1. And then my next shape, this triangle, so positive 1/2, base of 1/2, height of 1. I wrote those backwards. Okay, already running out of room. That was stupid of me. I should have done a bigger triangle than that, so I'm going to erase that. I actually don't have to do such a small triangle there. I should do this big triangle. There we go. So 1/2, change this base and height. So that was me just like trying to find matching shapes that will cancel out, but that left me with that awkward shape afterwards, which I don't want to deal with. So I'm going to do this triangle instead. 1/2, base is 2. No, it's not, because it doesn't go all the way to 0. Base is 1/2, so 3/2. Height is 3. And last I have to do that circle. Now that circle is going to be hard because I don't actually want the area of the circle, unfortunately. I want the other portion. So the circle itself goes this way. I want this area. So what I have to do is find out the area of this rectangle or square, and then subtract out the area of my quarter circle, and then I'll get the remaining portion. So I'm going to add the area of that rectangle, which I can't read this, and now I'm going to erase all these shapes. Add the area of that rectangle, so that's this. That's going from 2 to 5, so that's 3 by 3. Why is that? Like, it randomly does whatever color it wants. 3 times 3 minus the circle. The circle, a quarter circle would be 1/4 of pi r squared. Pi r, it says that the circle is centered at 5, 3, and it starts here at 2. So its radius is 3. So pi r squared. All right, so this is all of those shapes. So it's a little obnoxious, but it's not doable. It's triangles, a rectangle, and a circle. And I'm going to close my parentheses here and see what we, edit, undo, and see what we got. Do some math. So I'm going to make this one group, make it smaller, put it up here. All right, so I have 7 equals. Integral from -6 to -2 of f of x dx plus, now in here I have 1/2 of 1 times 1 minus 1/2 of 1 times 1, those cancel out. And then I have -1/2 times 1/2, that's a -1/4. And then I have, so that's that. This is 1/2 times 3/2 times 3, so that's a positive 9/4. That's this, plus 9. Minus 9/4 pi. All right, awesome. So now 7 equals the integral. I don't want to keep rewriting the integral. Integral, and then I have, this would be 8/4, so that's 2, plus 9 is 11. So plus 11 minus 9/4 pi, and I'm just going to solve for that integral. So I'm going to subtract the 11. I have -4 equals the integral from -6 to -2 of f of x dx minus 9/4 pi. And when you move it to the other side, -4 plus 9/4 pi equals the integral from -6 to -2 of f of x dx. So that is how you would find that, and I just wrote halfway in that problem. So wow. So you have to really know here that it's asking you to find the area of the shapes. And you have to be able to find that quarter circle. That quarter circle is the hard part. All right. So it's a pretty long part A. And you could put that pi in the numerator with the 9 if you want it, and leave it as 9/4 minus 4, or -4 plus 9/4, or you can do the pi after, it doesn't matter. All right, so that's part A. Part B, evaluate the integral. I'm going to do B right here. Oh, erase this. I'm going to do B right here. The integral from 3 to 5 of 2 f prime of x plus 4 dx. So when I integrate this, I'm going to get 2, which is a scalar. Integral of the derivative is the original f of x, and the integral of 4 is 4x. and this is from 3 to 5. Okay, seems easy enough. So plug in the top, it's top minus bottom. This is going to be 2 times f of 5 plus 4 times 5 minus 2 times f of 3 plus 4 times 3. So I can read f of 5 and f of 3 straight from my graph. F of 5 is 0, so I have 2 times 0 plus 20 minus f of 3. Not clear. Good thing it gave it to me here. 3 minus square root of 5. So 2 times 3 minus square root of 5 plus 12. So I have 20 minus, I'm going to distribute here, 2 times the 3 is 6. This will become a plus 2 square root of 5 minus 12. Distributing that negative. And then I have 20 minus 6 minus 12, that's 2. 2 plus 2 square root of 5. There you go. Again, this was being sure that you could know to read the values from the graph and not forget to integrate that 4. A lot of times we're so focused on the f part that we forget about the constant, or you would typically forget about that constant. I'll make that go away. There we go. All right, part C. The function g is given by g of x, which is x integral from negative 2 to x of f of t dt. Find the absolute max. So that means derive and set equal to 0. So I'm going to derive this, and when you derive the integral, it drops off, right? These two cancel each other out. So I just have f of, and my t will turn into an x, because technically the replacement does take place, but we just don't show that step. F of x. I want to know where this is equal to 0. So I'm going to look where f of x is equal to 0. That will tell me extrema. My graph, thankfully, is of f of x. So I can read those values straight from the graph. So looking at my graph, the zeros, the places I cross 0 are here, which is at negative 1. So x equals negative 1. Here, which is 1/2. And here, which is 5. I want to know which one of those are the absolute maximum, which means I need to plug them back in. So I also actually need to test my endpoints. So I need to also test x equals negative 2. So I'm going to do all of these integrals. I'm going to integrate from negative 2 to negative 1 of f of t dt. So f, I'm just going to do this area under the curve. I'm going from negative 2 to negative 1. That's the area of that triangle. 1/2 base times height. 1/2 1 times 1 is 1/2. That's when x is 1. Okay. Next, when x is 1/2. When x is 1/2, integral from negative 2 to 1/2. Notice that I'm not going to do this part. This triangle and this triangle cross each other out. So then my integral would be just the area of that leftover triangle, which is a negative 1/2 base times height. So negative 1/2 times 1/2 times 1, or negative 1/4. So already that one's not the maximum. Next, we're going to do to 5, which we've already done from negative 2 to 5. We did that up here somewhere. I know I already did it. Yes, we did negative 2 to 5 here. Right there. That's all of this. We already did that area shape, so I'm not going to waste my time doing it again. It ended up being this. So integral from negative 2 to 5 of f of t dt was 11 minus 9 over 4 pi. And then lastly would be -2. But the integral from -2 to -2 of f of t dt is 0. You have no space there, no area there, so it's 0. So which one is the biggest number? Well, I'm going to put in my calculator and see if 11 minus 9 pi over 4 is bigger than 1/2, and it is. It's not at 3.93. So the maximum, the absolute maximum is max is 11 minus 9 over 4 pi. The math here is your justification, having all those endpoints or possible extrema, and then all their y values, the integral values. That is your justification. And last, part D. Part D looks intimidating because it's got arctangent, it's got all kinds of stuff, and it's a limit, which you guys already don't like limit. You don't feel comfortable with limits because it's not, like, we don't do it as often. 10 to the x minus 3 f prime of x over f of x minus arctan x. I'm going to plug in 1 and see what I get. 10 to the first minus 3 f prime of 1 over f of 1 minus arctan of 1. So let's see what we got. 10 to the first is 10 minus, can I read what f prime of 1 is? Yes, I can just take the slope there. So my slope would be rise over run. So this is rise 2 over 1. So that's going to be a value of 2 over 1. F of 1, I can also read that right from the graph, is 1, the actual coordinate. And then arctangent of 1, this is saying when tangent equals 1, what is theta? That happens when your cosine and sine are the same, which is pi over 4. So I have 10 minus 6, and then this is 4 over 4 minus pi over 4. So this is 4 over 3 pi over 4, or 4 times the reciprocal, 4 over 3 pi. And then I'm going to cancel out my 4s. I need a different color. So I get, I already wrote an equal sign, 1 over 3 pi. Perfect. In the actual answers online, they don't even simplify. They stop right at the 6 over 1 minus 4 pi. So wherever you stop is fine as long as your math is correct. And honestly, if I was to have made a math mistake there and circled it, they will take my wrong answer. If you make a math mistake and you haven't circled it, they will not take your wrong answer. So be careful. All right, there's that. And we'll do one more from 2019. This one. Functions f, g, and h are twice differentiable functions with g of 2 equals h of 2 equals 4. Okay, so for g, when x is 2, y is 4. For h, when x is 2, y is 4. I don't know why I'm writing this. I'm just writing it because why would they state that? I feel like I probably need to know their y values at some point. The line y equals 4 plus 2/3 x minus 2 is tangent to both g and h, which means that this bad boy is a derivative. I shouldn't use f prime. This is my slope, which is my derivative. So this means that g prime is 2/3 at 2, and h prime is also 2/3. Okay. Again, I don't know what that gets me. Oh, well, part A, right away, says what is h prime at 2? H prime of 2 equals 2/3. You read that straight from that equation. Tangent line. No calc involved. Part B. Let A be the function given by a of x, which is 3x cubed h of x. Find a prime and a prime of 2. Okay, I have to do product rule. So a prime is 1 original, so I'm going to leave 3x cubed times the derivative, h prime of x, plus the other derivative, so this is going to be 9x squared, and the other original, h of x. So there's a prime. Now I'm going to do a prime at 2. So I have 3 times 2 cubed times h prime of 2 plus 9 times 2 squared times h of 2. So 2 cubed is 8, so this is 3 times 8 times h prime of 2. I just answered in part A, that was 2/3, plus 9 times 4, h of 2 was given to me, it is 4. So now I can simplify. I've got a 3 on top and a 3 on bottom, so I have 16 plus 9 times 4 times 4. 9 times 4 times 4. 144. Plus 16 would be 160. So this one is not really that involved, but this would be great for them to put on this year to make sure you know what you're talking about. Can you do product rule? Can you use the information given to you? Can you read the slope out of a tangent line? All of those things. Can you be thrown 3 different lettered equations and now a 4th lettered equation, A, and keep them straight? It is really important. All right, part C. The function h satisfies h of x, which is x squared minus 4 over 1 minus f of x cubed. It is known that the limit of h of 2 can be evaluated using L'Hopital's rule. That means I get 0 over 0. Or infinity over infinity, but we're talking about 2, so it's not going to be infinity. Use the limit of h of x to find f of 2 and f prime of 2. Okay, first of all, I know that the limit of h of x has to be, at 2, it has to be 4. So the limit of, as x approaches 2, of h of x has to be 4. That's because my function is defined there, and since my function is differentiable, it is continuous, and you do need to state that. Anytime you see the word, the function is differentiable, just write down continuous, it is continuous, because that's what that implies. So I know that that's 4. I know that I should be getting 0 over 0. If you were to plug 2 in, 2 squared minus 4 is 0. So that means the denominator, 1 minus f of x cubed, is also 0. Which means that, hopefully you can tell, 1 minus something is going to be 0. This means that 1 is equal to f of x cubed, which makes f of x equal to 1. So I at least know that value. That doesn't help me. That doesn't answer any of my questions. But that at least gives me something to work off of. So now I'm going to do that L'Hopital's rule. L'Hopital's rule is derive the top, derive the bottom. So I'm going to have the limit as x approaches 2 of, I got 2x on top, and on the bottom my 1 will drop off, my negative will stay, the 3 will come down. I'll have f of x squared times the derivative. This is chain rule. And this is going to be equal to 4. I know that because, again, this is the limit of h, and h is a continuous function. H is defined at 2 to be 4. So now I can kind of try to solve this and see what I got. I'm going to plug in that 2. I'm going to scroll this down. Okay, so I've got 2 times 2 over negative 3 times f of 2 squared times f prime of 2 equals 4. Okay, so I can figure out a little bit more. This helps me. This is actually f of 2. I just made it a 1. F of 2 being 1, because that's what we were solving for, the limit when x is 2. So what I have here, let's see where this can go. I have 4 over negative 3. I know that f of 2 is 1 squared times f prime of 2. So that did help me. F of 2, I knew I needed that. Okay, is equal to 4. Okay, so now I got to solve. See what I got. 4 over negative 3 f prime of 2 equals 4. I just got to get that variable by itself. It's in the denominator, so I'm going to multiply by it. Negative 3f prime of 2 times negative 3f prime of 2. They'll cancel each other out. So I have 4 equals negative 12 f prime of 2 and divide by the negative 12. So negative 1/3 is f prime of 2. So it really wasn't that bad. You just kind of had to know where to start. And I think that's half of the problem with calculus is you look at these things and you're like, okay, I know what L'Hopital's rule is. I know what a limit is. I know what it means to be continuous. How do I use it all together? You honestly just got to jump in and start something, or else you're just going to stare at this problem. So start something, see what you can do. You know it should be 4. Hopefully you can make that connection, and then you can set up an equation which allows you to solve. All right, and then part D is a conceptual question. It says it's known that g of x is less than h of x or equal to for all of 1 to 3. Let k be a function satisfying g of x is less than k of x is less than h of x or equal to between 1 and 3. Is k continuous at 2? Well, I know that g of 2 is 4. I also know that h of 2 is 4. And you know that this is true, right? K is between g and h. So if you have 4 is less than or equal to k of x is less than or equal to 4 because you had g of x, which is 4, and h of x, which is 4. That means that k of x must be 4. And if k of x is 4, that means it is continuous at 2. That was just a conceptual. Could you pull it together and make it fit? Yes, you can. Since g and h are both continuous functions and they're both 4, there's no number between 4. So it's got to also be 4, which means it's a continuous function. Great. That is the top 4 from last year's FRQs. I know this is a little bit long. Just take it in pieces. And that's about it. Thank you.